All right, guys, sorry I got cut off in that last one, but it was kind of in a good spot anyways. So we still need to go over zero exponents a little bit more. We already talked about them a little bit in that last video, but then negative exponents. So again, any zero exponent will always just make the whole thing 1. So any number to the 0 power is simply 1. So when we have 15 to the 0 power, that's just 1. This crazy fraction thing to the 0 power, just 1. So, oh my God, look at all that. Let's actually talk about our negatives first. So what we also need to keep in mind is negative exponents are not allowed, can't have them. So to make them not negative, you need to move where they're at. And when I talk about moving a number can be in one of two spots. Your number can either be in the numerator or the denominator. So since this number is in the numerator, because I can always be over 1, and it has a negative exponent, it needs to move to the denominator, which makes it positive. So that's what we did here. And then this negative exponent is in the denominator, so I need to move the number to make it positive, and when it moves, it's up in the numerator now. So we can actually think about this a couple of different ways. Oh, look at all these. Let's just start with all of them then. So number 1 over here, what we can think about this as is because I'm dividing and the bases are the same, I could do 2 to the 2 minus negative 3 power, because when we are dividing, we subtract, which a double negative will really make it a plus. And so we end up with 2 to the 5th. Now, another way of thinking about it is that this negative needs to move up. And so then what we have is 2 to the 2nd and 2 to the 3rd, which since we're multiplying, we just add. So 2 to the 5th. Either way, we get 2 to the 5th, which, oh my gosh, I should just do 2 times 2 times 2 times 2 times 2 is 32. Okay, so I'm going to do it both ways a couple more times just so that you can see. And then I'm just going to kind of go through the way I would normally go through it. So with this one here, because I'm dividing, I could think of this as m to the 1st minus negative 4, which a double negative is a plus. And so we get m to the 5th. Or again, another way to think about it is I got to move my negative exponent. And so I get m to the 1st. M to the 4th moves to the top, so there's no bottom left. And then because I'm multiplying, I just add. But I still end up with the same answer of m to the 5th. Okay. Similarly, on this one, I could think of this as p to the negative 8 minus 3, because when I divide, I subtract. Now, this one doesn't have a double negative, so I'm not going to add. I mean, I am going to add, but when I do add, I have a negative number still. So it's negative 11. And you are not allowed to leave negatives in your exponents. So to make it not negative, I need to move where it is, which means it needs to go to the bottom. And I would put a 1 on top as a placeholder. Or another way to think about it is take this number, move it to the bottom. So 1 is left on top, and we have p to the 8th, p to the 3rd. And since we're multiplying, I would just add, and I'd still end up with that 1 over p to the 11th, like we had. So this one here, again, because my bases are the same, and I'm dividing, I could just subtract. So b to the negative 4th minus negative 5. So double negative here means I'm going to change that to a plus. But a negative 4 and a positive 5 is 1. So this is just b to the 1st, which is just b. Now, another way of thinking of it is since this b is negative, it moves to the bottom. And since that b is positive or negative, it moves to the top. So these b's are switching spots, and I'm left with b to the 5th over b to the 4th. And again, because I'm dividing, I would subtract 5 minus 4, which is 1. So either way, I get the same answer. Alrighty, moving right along. Now, this whole set of parentheses here is to the 0 power. Anything to the 0 power is 1. So really, this first simplifies to 1 on top, and then on the bottom, I still have all this stuff. Anything to the 0 power, simply 1. Totally gone. It's just 1. Now, I don't have any common bases, like I don't have any same bases, but the only issue that I have left here is that I cannot have a negative exponent, so this W needs to go to the top. But 4 has a positive exponent, so it stays, and Y has positive exponent, so it stays. The only thing that's moving is the letter with the negative exponent. So, and you don't really need to leave the 1 by the W, but alrighty, getting a little harder. Here I have parentheses, so I'm going to distribute. And the reason I didn't on this one is because it was just 0, and I knew anything to the 0 power would be 1. I'm also going to distribute on the bottom. And so we'll have, when I distribute, I multiply. So a to the 4th, b to the 6th, and then a to the negative 2nd, b to the negative 2nd. Now, me personally, after I distribute, I like to, if I'm dividing, subtract. So 4 minus negative 2, double negative means I'm really going to add. That's going to be a to the 6th. The b's are the same, and since we're dividing, 6 minus negative 2, double negative, is add, so b to the 8th. Now, excuse me, sorry. Now this one, I could move both of these up because they're negative, and then I would just end up adding anyways, but it kind of saves me a step. Like I don't have to write it out as much. Okay, this next one here, no parentheses, so I don't have to distribute, but these x's, since they're the same and we're dividing, I'm going to subtract. And 4 minus negative 2 is 6, so x to the 6th. So really no more bottom. I don't know why I wrote that. And then y to the 0 is just 1, so I don't really need it. Sneaky stuff. Okay, on to the next. I need to distribute the 2 on top and the 4 on bottom. So I'll have 6 to the 2nd, a to the negative 2nd, because when I distribute, I multiply, and b to the 2nd. And then on the bottom, we're distributing the 4, so b to the 8th. Now, the 6 to the 2nd doesn't have any other common base, so 6 to the 2nd is just 36. The a doesn't have any other common base, but it's negative, so it can't stay on the top. It needs to go to the bottom. And then finally, when I do the b's, because I'm dividing, I'll subtract, and I'm going to have 2 minus 8, which is negative 6, which really means it needs to go to the bottom. So when I'm doing it in my head like that, if I subtract and get a negative number, I'm just going to put it to the bottom. Or another way to think about it too is I always just put the b where the bigger number is. So when I subtract these, I get 6. And because the 8 is larger, it goes to the bottom. So hopefully that kind of makes sense, but we're going to do more like that. So let's try again. On number 9 here, I'm going to distribute the 2 to the parentheses, and then there's no more distribute. So we'll have 3 squared, r squared, t squared, u to the negative 4th, all over r to the negative 1st, t to the 2nd, u to the 7th. Then as I go through, there's no other base of 3, so I'm just going to do 3 squared, that's 9. Now the r's match up, and so because I'm dividing, I subtract, and I do 2 minus negative 1. Double negatives of plus, so that's going to be r to the 3rd, and it's positive, so it goes to the top. And the 2 is bigger than negative 1, so it stays on the top. Then when I do the t's, 2 minus 2 is 0, and anything to the 0 power is 1, so t is gone. And then lastly, negative 4 minus 7, because we're dividing, I subtract, is negative 11, which means that the u is going to go to the bottom and be positive. And also, because the 7 is larger, the u is going to go on the bottom. So that's kind of where we're bringing it all together and like doing all the things. So got a couple more like that to try. Now, I don't need to distribute on the top, but I do on the bottom. So we'll distribute this negative 1 to each of those. So we'll have m to the negative second, t to the negative third. Now, I could instead move all the negatives, but I just like to subtract. So because the m's are the same, negative 3 minus negative 2 will really make it negative 3 plus 2, which is negative 1. So that needs to go to the bottom. Also, negative 2 is bigger than negative 3, and they are 1 apart. So it goes to the bottom because the bigger number is on the bottom. And then negative 3 and negative 3, when I subtract those, that's going to be plus, so that's 0. And anything to the 0 power is 1. So really, I have to put a 1 placeholder on top here, but there are no t's left because anything to the 0 power is 1. So that's just gone. Which, if you look at the next, anything to the 0 power is just 1. So that's just 1. The whole thing just goes away. Okay, last but not least, we're going to distribute this negative 3 exponent. But there's no distribute on the bottom. So we'll have negative 2 to the negative third, m to the negative third, and n to the negative 6, because when I distribute, I multiply. And I got 4, m to the negative 6, n to the fourth. So since these bases aren't the same, I'm just going to do negative 2 to the third and then move it to the bottom because it's negative. So negative 2 times negative 2 times negative 2 is negative 8. And the negative 8 needs to go to the bottom because this exponent is negative, so it needs to move. Now the 4 stays put because it has a positive exponent. Now with my m's, because we're dividing, I'll subtract, and negative 3 minus negative 6 will make it a plus. So that's 3. Since it's positive, we'll stay on the top. Also, negative 3 is bigger. Then the bigger number for the ends is on the bottom. So whatever I get when I subtract, it's going to go on the bottom. And negative 6 minus 4 is negative 10, but it'll be positive 10 down here. And then I just feel like I should probably multiply that. So m to the third over negative 32 n to the 10th. Sorry, that's like squeezed in there. Okay, so I know we have this whole other page. I'm going to leave that for some more examples. And so, yeah, I'll see you in the next one.